Hey, welcome to Lesson 6 in Terraform Zero to Hero. I'm your instructor, Evan Gertis. We're going to talk about modules today. Okay, so finding and using modules. Every page in the Terraform registry has a search field for finding modules, so you can find modules for VPC, Vault, Database. Typically, I use the AWS module for VPCs for setting up a virtual private cloud. It's a great module. The syntax for referencing a module in a registry is the namespace, the name, and the provider. So you'll have something like my module make infrastructure Evan, for example, just kind of broken up in this sort of naming convention. Here's an example. So this module is console, and you have HashiCorp console AWS. So the namespace here is HashiCorp, the name is console, the provider is AWS, and we're constraining it to version 0.1.0. So you can also use modules from a private registry, like the one provided in Terraform Cloud. You just have to specify the string like so. You have your host name, namespace, name, and provider. Here's an example. So VPC, you have the host name, app.terraform.io, namespace, example corp, and then name, VPC, and then provider, AWS. So here are some common problems that you run into with modules. Understanding and navigating configuration files, updating configs can become more risky. You're going to have to constantly rerun init every time you change something or add or remove something to a module. And you have lots of duplication. So you might want to share parts of your configuration. So these are some common problems that you run into. What are modules for? So we can organize our configuration, encapsulate it, reuse it, and provide consistency. So modules make it easier to navigate, understand, and update your configuration by keeping related parts of your configuration together. We can consolidate everything into a module. Another benefit of using modules is to encapsulate configuration into distinct logical components, kind of like object-oriented infrastructure as code. We can reuse our configuration. So keeping our code dry. If you're not familiar with programming terminology, dry is do not repeat yourself. So writing all of our configuration from scratch can be time-consuming and error-prone. It also helps us provide consistency and ensure best practices. So there have been a lot of issues with security. If something is not configured properly, and when we have a module, we have consistency. So we can assure ourselves that whatever we're producing is the same consistent blueprint over and over again. What is a Terraform module? Well, it is a set of Terraform configuration files in a single directory. When you run Terraform commands from such a directory, it's considered to be a root module. In this case, we have our main TF variables and outputs, and this is just a minimal module. So Terraform commands will only directly use the configuration files in a directory, which is usually the current working directory. Here are some best practices for writing a module. So you start writing configurations with modules in mind. So you're always trying to think, is there a way that I can consolidate this into a module? And then you want to use local modules to organize and encapsulate your code. And then sometimes it's more beneficial to just use the public Terraform registry for completing some sort of task, provisioning infrastructure. Like I said, the VPC module from AWS is very useful. And then you can publish and share those modules with your team. So we have this concept of input variables. Input variables serve as parameters for a Terraform module, allowing aspects of the module to be customized without altering the module's own source code and allowing modules to be shared between different configurations. So let's compare Terraform modules to functions. Input variables are like function arguments. Output variables are like function return values. And then we have locals. Locals are like temporary variables instead of a function. So this is what a set of variables could look like. Each input variable accepted by a module must be declared using a variable block. For example, in this case, we have a variable Docker ports. The label after the variable keyword is a name for the variable, which must be unique among all variables in the same module. So how do we use these input variables? Within the module that declared a variable, its value can be accessed from expressions such as var.variable name. So in this case, we're declaring a variable set password, and then we're assigning it to this attribute create password. And the syntax is var.setPassword. We'll touch on type constraints. So the type of argument in a variable block allows you to restrict the type of variable that will be accepted as the value for the variable. So the supported types currently in Terraform are string, number, and Boolean. We can create, we can use these type constraints whenever we're creating complex objects, such as a list or a set or a map, or an object in tuple. So the keyword any may be used to indicate that any type is acceptable. All we have to do is place the type within the parentheses of the constructor of the object. So it's useful to document your variables. We want to be able to understand what the purpose of this variable is. So there's an attribute called description in each variable block. Within the description, you can add a brief description of what the variable's purpose is. In addition to type constraints, a module author can specify arbitrary custom validation rules for a particular validation block. Like in this case, we have a condition here that the length of the variable var.imageID must be greater than 4, and we're evaluating that the substring contains the string AMI. The condition argument is an expression that must use the value of the variable to return true if the value is valid, or false if it is invalid. If the failure of an expression is the validation decision, use the can function. So the can function works like this. We saw the example before where we're trying to find the AMI substring. In this case, we can just do a regex, and can evaluates the given expression and returns a Boolean value indicating whether the expression produced a result without any errors. All right. So we can load vars, variables, in various ways. The first way is in the Terraform Cloud workspace. We could also individually declare each variable with a tac var command, and we can do it from the command line. And then we can also create a variable definition file. We could also use env vars, environment variables. This is what it looks like when we're declaring variables from the command line. We just do tac var and then specify the variable. And then to use a tf-vars file, we can specify the var file in the command line like so. So variable definitions file uses the same basic syntax as Terraform language files, but it only consists of variable name assignments. So it's just a big file of variables. We could also use environment variables. So Terraform will search environment for its own process, and it'll look for environment variables named tf-var, followed by the name of the declared variable. So tf-var image ID AMI ABC123. It's the same thing that we're doing here, AMI ABC123, which is the same thing that we're doing here, image ID AMI ABC123. So when variable values are provided in variable definitions file, Terraform's usual syntax can be used to assign complex type values like lists and maps. We saw that here. So this is the precedence here. Terraform loads variables in the following order. So first it goes environment variables, then .tf-vars, then .tf-vars.json, then auto.tf-vars or auto.tf-vars.json, then var, and then -var -file. Now we'll learn how to call a child module. So to call a child module means to include the contents of that module into the configuration with specific values for its input variables. For example, here we're calling the child module app cluster, and we're passing in an argument of servers set to 5. So modules are called within other modules using module blocks. So within that body of the curly braces, that's where we're going to specify the arguments for the modules. Now, all modules require a source argument. We have to specify where that source for the module is coming from. You'll find that in the .terraform modules directory. After adding, removing, or modifying module blocks, you must return Terraform init. So once you change something in a module, if you add something or you remove something, you will have to run Terraform init. So a child module can declare output values to selectively export certain values to be accessed within the calling module. So we can use the outputs from our modules in our resources. For example, in this case, we're making a resource AWS ELB, and we're setting the instances argument in this resource to the return from module.servers.instance IDs. Okay, so when an existing configuration is split into child modules, moving resource blocks between modules causes Terraform to see the new location as an entirely different resource from the old one. So when passing resource addresses to Terraform state move, resources within child modules must be prefixed with module.module name. Here are some other meta arguments for modules that have a special meaning. So a version, we can specify, we can tie a module to a version constraint. We can specify count and for each. Both of these arguments create multiple instances of a module from a single module block. You can also specify providers explicitly. So providers is a map whose keys are provider configuration names that are expected by a child module and whose values are the corresponding provider configurations in the calling module. We can also specify another meta argument here, depends on. So depends on creates explicit dependencies between the entire module and the list of targets. Then we have module versions. When using modules installed from a registry, you want to explicitly constrain the module to acceptable version numbers to avoid unexpected or unwanted changes. The last thing you want is someone to change something in a module that's in a registry, and then all of a sudden all of your code breaks because you haven't constrained it to the proper version. We can also declare multiple instances of a module. To do that, we'll use the for each or the count argument. Here's an example. So in this case, we have module bucket, and then we're using for each argument here, and we're passing in assets and media. And each one of these will use a different name. On the right-hand side here, we actually have the module itself. So the variable name, and then we have a resource. What this is doing is it's creating an AWS S3 bucket, and it's using the name from the argument that's passed in here. So we're going to create a bucket for assets and a bucket for media. So then we have multiple instances of a module. Resources from child modules are prefixed with module.module name, module index. In our example, .publish bucket, that module contains the S3 bucket.example. And so our two instances of this module produce S3 buckets with resource addresses of module bucket assets, .aws S3 bucket.example, and then module bucket media.aws S3 bucket.example. Now we'll talk about providers within modules. This is another one of the meta arguments. We can either pass a provider implicitly through inheritance, or we could use the provider's argument within the module block. This is what it looks like to just declare a provider. In this case, we're using the required providers block inside of a Terraform block. So this module requires a particular version for a specific provider. Now, if we want to do implicit provider inheritance, all the modules that we're using will inherit from its parent. So here we're declaring a specific provider with an AWS region, and that provider will be passed down to this child module through inheritance. We can also pass providers explicitly. So to do that, we'll have to specify the provider's argument within the module block. Right here, we have the provider's argument in the module block, and we're using US West 2. So passing providers explicitly. Once the provider's argument is used in a module block, it overrides all the default inheritance behavior. So passing this in is going to override the default provider inheritance. We're not going to use US West 1. We're actually going to use this aliased provider, US West 2. So here's an example of passing multiple providers explicitly. In this case, we've specified an alias of US West 1 and US West 2 for both these providers. And then we have a module tunnel. And then we're passing the providers in. We're setting the source, the provider that has the alias source and the provider that has the alias destination. We're setting those to US 1, US West 1, and US West 2. So this is going to be used here. This is going to be used here. And then within that module, we have a provider AWS with alias source, AWS destination. So the subdirectory of tunnel must then contain proxy configuration blocks like the following. That's going to be it for this lesson. I hope that you enjoyed it and keep on learning Terraform. Thank you for watching.